All right, good morning and welcome to Cisco Live. I'm sure you guys would have had an amazing time this week having watched those technical sessions, the breakouts, the ILTs, and of course, the DevNet. Today's topic of discussion is expedite your troubleshooting with SD-WAN Manager Tools. Before we deep dive, a little bit of introduction about myself. I'm UmaMohanty. I have been with Cisco for around 13 years now. And currently, I work as a technical leader for the customer escalation and adoption team in SD-WAN. All right, with that, a little bit of logistics slides. And I'm sure every one of you would have joined this WebEx Teams room for now. I would really urge you, please do join that room. And during the session, I have a couple of my colleagues monitoring it at the moment. So if you have any questions, do drop it on to the WebEx Teams room. If at all anything goes unanswered, I'll take a look at them as soon as I'm done with this session. This will be moderated till 14th of November, but it can stay open as long as you guys need it, as long as you guys want it. I still have some of my previous sessions, WebEx Teams room still open. Whenever I get through to some good amount of blogs, let's say some troubleshooting scenario which is pretty interesting and helpful in your troubleshooting approach, I do drop in a note over there. And people have reached out in the past to me if they figure out some problems, if they have some issues, do not know whom to reach out or so. They have, so that channel has always been open. So please do join that room and keep that channel open, keep that discussion open. With that, let's have a quick look at today's agenda. We start off with the dub or what and why of SD-WAN. Top it up with some of the monitoring and troubleshooting challenges that we face in our day-to-day SD-WAN life. And then comes the key piece of the session where we go through all those inbuilt tools that come along with the SD-WAN Manager itself and how we can utilize them in our troubleshooting approach in order to resolve issues much, much faster. The next section is a pretty interesting one where we build our own API workflow. Now, I have a very beautiful story how we landed up to this scenario. There were some customers who had these issues for a longer period of time. We worked with them. We knew what their requirements were. We gathered that. And based on it, we went ahead and built the API workflow for themselves to automate that particular pre-check. I'll come to that when I come to the API section of it. I'll summarize the session in the key takeaways and open up the room for any questions after that. We good? All right, so let me start with this. What do you see here on the screen? Or let me put it this way. Any coffee lovers, coffee snobs over here? 1, 2. Yeah, great. That would probably be me if at all one certain morning I wake up and my coffee machine is broken. Now I have two ways to go from here. Either I can start looking at the lengthy manual that comes with the coffee machine one by one and try to troubleshoot or try to see if I can fix the problem. Second way, I can probably open up my laptop, go through some blogs, go through some of those who have faced similar kind of issue with same brand. I can go through those blogs and try to fix it. But the problem with this approach, both of these, is that I really don't know if I'm in the right direction or if my approach is correct towards fixing this, isn't it? Now here comes the third approach. Let's say this coffee machine had a diagnostic button. I could have easily pressed that diagnostic button. It would have done all its tests internally and come up with an error message. And based on that error itself, now I know that I'm in the right path to try to fix this problem. And this analogy kind of fits in towards today's session, where we use all those inbuilt tools that are available with our SD-WAN Manager in order to troubleshoot issues, in order to or reduce the mean time to resolution of our faults in the network. With that, let's move ahead towards our first section, the dub or what and why of SD-WAN. Before I go there, a little bit of session objectives, just to keep everyone on the same page. We'll discuss a brief overview of SD-WAN. We'll go through in detail about some of the tools that are inbuilt with SD-WAN Manager itself and see how exactly these tools can help us in some of those scenarios to troubleshoot issues. We'll also touch upon a little bit on the API workflows. This SD-WAN Manager has a rich set of APIs which we can integrate with any of those third-party tools, and let's see how exactly we go about reducing some of that mundane task or repetitive task of yours. By the end of this session, I really hope every one of you gets a better understanding of these tools and the API workflow and how exactly we utilize them to reduce our mean time to resolution of the faults. So the non-objectives, we will not cover any of the installation aspects. We will also not cover SD-WAN analytics. But having that said, if you still have some questions around these or SD-WAN in particular, I would really urge you, do put a note onto the team space, okay? And we can further discuss over it. So, why SD-WAN? And this is how probably the hardware-based WAN of yesterday would have looked like. We had our branches connected via the MPLS or VPN connections towards the DC or the regional hub. And at any point in time, let's say, we had to go to the cloud applications or some of those cloud service providers. We had to go via the DC. We had to branch it out via the DC itself. Now, if you ask me, that's a little inefficient way of doing things, because now that we see a trend where all of our applications are starting slowly to move towards the cloud, that is what our WAN should be following. Let's see how SD-WAN caters to some of these challenges. SD-WAN as such, it's a transport agnostic technology. What I mean by transport agnostic is, it doesn't really matter what kind of transport we have. We might have MPLS, internet, 4G, LTE. It just needs that reachability. On top of it, we can build our overlay. And now that we are talking about sending traffic over some of these unsecured channels like internet, LTE, security becomes our major concern, isn't it? These tunnels that come up with SD-WAN, they're all IPsec encrypted, and that takes care of your security. One of the key pieces that SD-WAN brings onto the table is segmentation. What I mean by segmentation is, we can have a VPN 10 where we can choose the traffic from one branch in order to go to the other branch has to go via the data center itself. You might have some audit requirements, you might have some security policies related to that particular branch or that particular traffic. We can do that. And at this same point in time, we can have a VPN 20 where we can choose the traffic to go from one branch to other directly without the need of that regional DC itself. And that's the control that SD-WAN gives us. That's the control that SD-WAN gives us over the topology. We can choose for ourselves what kind of topology would we like to implement over here. If we talk about those cloud applications and cloud service providers, right? We can utilize infrastructure as a service or software as a service. We can leverage them and branch it out directly from the branches, from our local branches itself. There is no longer a need for us to go to the regional DC. We can get that done as long as our ISP permits. And this is one major aspect, again, application-aware routing, and I really want to take some time over here. So, if we talk about some decades ago, before the world of SD-WAN, most of our application traffic, it was being controlled by our routing protocols, isn't it? At any point in time, any other path goes down, they would do their own calculation, come up with the next best path that is available, and switch over the traffic to that. It was working good for us. It was working good for us for so long, right? But these are all blackout conditions that we are talking about. When we talk about a transport agnostic technology like SD-WAN, where it doesn't really matter to us what kind of transport we are having, the gray out condition becomes more vulnerable, right? What I mean by gray out conditions is loss, latency, jitter. The tunnels that come over in SD-WAN, the data tunnels that come up in SD-WAN itself, they come up along with BFD. And we leverage BFD to get those loss, latency, and jitter parameters. And now that we have it, what exactly do we do with that? We can define application-aware routing policy where we can choose the SLA for those particular applications itself. There's a small example over there, but what we can do, we define that, we push it directly from our SD-WAN manager towards our devices, towards our edges itself. And at any point in time, if there is any violation detected on those particular parameters, the traffic is automatically switched over. Now, there'll be a question coming to your mind. Is this real time? The answer to that is a yes and a no. I'll tell you. Why a yes? Because how app-aware routing basically works is, by default, there is a 10-minute bucket. Within this 10-minute, it will keep on probing, it will keep on getting the loss, latency, and jitter parameters via BFD. And it will take 6 such buckets into account, take the average, and that's where it concludes if at all the traffic has to be switched or not. So yes, the BFD probes are taken real time, but it actually has to average it out before it goes ahead and switches over traffic, if at all there is any kind of violation detected. Now there'll be one more question. What about the 7th one, 8th one, 9th one? App-aware routing, it works on a basis of sliding window. What I mean by that is, as soon as the 7th one comes in, we'll discard the very first one, take the latest 6 into account, average it out, and then come up to a conclusion if the traffic has to shift it or not. Along with that, now you'd be thinking, okay, 10-minute bucket, 6 of them by default, 60 minutes. Shall I wait till that longer in order for the traffic to switch? No, you don't have to. This time again is tweakable. But just a note over here, if at all you're tweaking this bucket or you're minimizing this bucket, you have to minimize the BFD timers accordingly. Otherwise, there are chances you'll have a very flappy link. Just to give you an example, if I might take 2 more minutes over here, just to give you an example, let's say we minimize the bucket to 1 minute or so. At the same point in time, we did not take care of the BFD timers, which is by default, let's say, 1000 milliseconds. So in that case, within this 1 minute, the probe count is 60 times it takes, right? If we lose one BFD packet over there, the loss percentage is taken as 1.66, right? So you have to minimize that timer accordingly. If we are minimizing the bucket time, you have to minimize the BFD timer as well. All right? So let's move ahead towards what is SD-WAN or the solution architecture. I won't go through. By the way, let me put this question. How many guys are troubleshooting at the moment with SD-WAN? Well versed? Okay, I'm going to get a tough time then. Okay, so we start off with the management plane, which is nothing but our single pane of glass. We get our day 0, day 1, day 2 operations done from there. We have our orchestration plane, which is the first point of contact for our devices. This is the point where our device gets authenticated into the fabric. We have our control plane, which is brain of the fabric again, and it kind of works similar to what a route reflector used to do in the classic routing world. And again, we have the data plane, which are nothing but our C-edge and V-edge devices. A little bit of deep dive. Again, management plane is the single pane of glass. We have our day 0, day 1, day 2 operations being done from here. We have good amount of monitoring and troubleshooting tools along with the SD-WAN Manager. And we have a rich set of APIs that we can utilize in order to automate our workflow, depending on our need. If we talk about the orchestrator, that's the first point of authentication. Except those virtual devices, all the C-edge devices, your certificate, your SUDI certificate is actually burnt inside the chip. And we use that as our trust anchor point in order to authenticate the devices. Along with authentication, it also plays a major role, I would say, during NAT traversals. Because in the world of SD-WAN, these C-edges might be sitting behind the NAT device itself, but they don't know that. When they reach out for the first time towards the validator is the guy who's going to tell him, oh, you know what? I'm seeing a different public IP, a different public port. So it plays a major role during the NAT traversals. And when the device is fully authenticated by the validator, that is the guy who's going to give the IP addresses of your SD-WAN Manager and the controllers itself. If we talk about the control plane, the controllers are the brain of the fabric. They are responsible to send these devices all the control plane information based on the policies that we have defined. It could be a data policy, app or routing policy. Everything is pushed via the controllers towards these devices. And this is the segregation where we do, this is the point where we segregate our management plane from the data plane itself. If we talk about our data plane, nothing much. It's our WAN edge routers based on the control plane information, the data policies, whatever we get from the controllers. Based on that, we will go ahead and put BFD tunnels. Whatever control plane information, whatever policies we have received, based on that, we will send or create our data tunnels towards different sites. If we talk about a little bit about the deployment methodologies, we have two types. It can be either on-prem, where we can host these controllers on top of our ESXi. Now in this case, as a customer, it's your duty to manage the infrastructure and along with it, any manageability or upgrade that we need to be done on these controllers. The infrastructure becomes a key over here at times. If we go to complex deployments where we have clusters being deployed for these SD-WAN managers or these controllers, that's where a little bit of complexity comes in, depending on the infrastructure. If we go ahead with the cloud-hosted mechanism, that's where you can choose for yourselves. If you want AWS, if you want Azure, Cisco will maintain its infrastructure itself. The manageability of these controllers will still stay with you, but the infrastructure is totally managed. You don't have to worry about that. We'll take care of any patches, anything that is needed in the infrastructure itself. Right, let's move ahead towards some of the monitoring and troubleshooting challenges. So first thing to start off with, know your tools. What I mean by know your tools is we need to really understand what kind of tools are there at our dispersal. And just knowing the tools is not enough. We need to also take care of what shall I look into. I mean, I have been troubleshooting with SD-WAN from past 3-4 years. And sometimes I also feel this dilemma, what shall I look into? Shall I look into the monitoring? Shall I look into the APIs? Shall I look into some of the test results or alarms, logs? There's so many things. So the first thing, of course, we need to understand what are the tools available for us, and we need to understand what kind of scenario are we in. If we combine those two data, that's where we can conclude to a point that what is the best tool to use over here. And now the third point, those critical intermittent issues. Guys, let me put this question again. How many of you have seen intermittent issues in their network? Right? Very critical at times. The reason being, by the time even if we think about using some tools, maybe talking to Cisco or getting someone to troubleshoot on the issue is gone. Puts us in a very bad state at that point in time, I would say. Because all we'll have is a little bit of symptoms that we had seen here and there, right? We really haven't been able to collect any logs in order to diagnose that issue, in order to root cause that issue. We'll see how the tools cater to that needs when I come. There's a very nice story over there. And again, the last thing, automation. That's the buzzword nowadays, isn't it? Anything that is repetitive, according to me also, anything that is repetitive, anything that is mundane should be automated. Should be automated. The reason being, the time we are saving over there, we can put to something very critical. And of course, it saves a lot of time. I'll show you in the automation section, the API section, how we landed up to that workflow and what kind of results it is giving us day to day right now. Right, let's start off with our first tool. Okay guys, just one question. How's the speed? Good, bad, worse? Good? Language, still crap? All right, let me take a sip of water. All right, the first tool to start off with, speed test. Why would we go with speed test first of all? If I talk about the era before we had these integrated in SD-WAN Manager, if somebody asks me, one customer comes to me and says, oh, you know what, I've got a new branch, I put some new ISPs over here, and I really want to test if whatever speed whatever speed I'm paying for, I'm getting or not. I would just go ahead and tell him there are two ways to go from here. Either you can put a iPerf server client kind of a setup between these sites, run the iPerf test, that will give you the exact one. Or else you can have two laptops loaded with some FTP, TFTP server client kind of a stuff, connected to the routers itself on both the ends, send some files or upload or download some files to get to the exact speed. But if we think in both these approaches, he has to spend or put some additional cost, put some additional manpower, isn't it? That has been made easy with SD-WAN Manager. There is no configuration that is required over here. We just have to click a couple of buttons on the GUI and we should be able to do the speed test itself. If we talk about it, it is used to evaluate, as I said, the WAN interface bandwidth between two remote sites or towards any of the public or private iPerf servers. The support for that started with 17.3 and later releases, and we have kind of two types of test. Either it is a site-to-site speed test or an internet speed test. If we talk about the site-to-site speed test, now that will be used, as the name suggests, between two sites. If you want to test the bandwidth of the WAN interface itself, we can get that done. We need to get into the devices, troubleshooting, and you would see the speed test over there. The device that I have selected over there, you can see the 8300. We can use the source circuit, the destination device, the destination circuit, and hit start. That's it. It will get all the things done in the backend and populate you the results. If we talk about internet speed test, it can be utilized to test the specified WAN interface bandwidth again towards any other public or private type of server. I'll come to that private part. Now, some of the customers, while we had this in the initial days, some of the customers came back, oh, you know what, we don't want to use the public type of servers. They do not give us the correct results. I have a private type of server of mine. Can I utilize that? We have that feature coming in the SD-WAN Manager after 2010-17-10 release itself. All you have to do is, as soon as you get into that, as soon as you get into the speed test page, there'll be IPv3 server and the port range that will be asked. If you have a private one, if you have a private IPv server, you can give the IP address, the open port over there, and you can test it. That was one of the feature requests some time back from the customers. Prerequisites, again. You good? Audible now?
No.
That's a good one. All right, prerequisites. No additional configs required over here. All we have to do is just get into the vManage administration settings and data stream should be enabled. Most of these tools that we will discuss in the upcoming ones, your data stream has to be enabled for that. That is the only prerequisite that we have. Now here's a snapshot from my lab devices itself. I didn't want to show how these are behaving, but yeah. I want to take some time over here to tell you what exactly happens under the hood. When we start the speed test from our SD-WAN Manager, what it exactly does is, it will just go ahead and instruct the devices that, you know what, there is a request, go ahead and start your IPv servers. We have all of those things inbuilt under the hood in the code itself residing with the device. What the device will do is it will automatically spin up a loopback 65529 interface. You would have seen that maybe on your devices. So it will automatically spin up a loopback interface 65529 on both these ends, assign it an IP address in the range of 11.x.x.x, and those x's will be taken care from parts of site ID, parts of your system IP. It will create that IP address. You don't have to bother about it. I'm just saying, as soon as it is instructed, it will create these loopback interfaces, and those loopback interfaces will be the source and destination for the test that is running. Please.
Are there any plans to allow like simultaneous speed tests? Because while I was troubleshooting, I needed to run the speed test on several routers, and SD-WAN Manager didn't allow me to do it. It says it's already the system is busy. Wait, and then the speed test is longer than normal, like speed test that you have over the internet, like Google speed test.
So if I get your question correctly, you want to run 2 speed tests in parallel?
Not on the same router. For 2, 3, whatever, like how many you need to run, but not just wait until one finishes.
Okay, okay.
Necessarily the same devices I'm touching. Devices, but it doesn't allow me to do that.
Okay. So here's a question. She was trying to run 2 speed tests in parallel from the same SD-WAN Manager, isn't it? That is not allowed at the moment. The reason for that is, again, when these instructions are provided towards the devices, there is a certain daemon working in the backend. And this one single daemon has to take care of all the speed tests. So in parallel, it can't be able to thread at the moment. But that's a good idea. I can take that as feedback for any further enhancements that can be put. But as I was saying, so once we have this speed test run and we have this daemon collect all the required things, the download and the upload speed, SD-WAN Manager, all it has to do is just run one single API and collect that data and throw it to you on the GUI. In short, what I'm trying to say here is SD-WAN Manager will just instruct. The rest of the things that are being done over here are done from the code itself on the device. That's why we do not need any kind of configuration changes. It will automatically take care of it. Right? Okay, packet capture. I'm sure is there a question?
Oh, sorry, just for the previous one, speed test.
Please.
I'm just wondering if the speed testing is restricted by the license, for example, HZ license. Or it doesn't matter, we can use this speed test tool to check the capacity of the link.
It is used to check the capacity of the link. It is not mandate with the license or the. If your question is, so here's the question. Let me repeat it again. Sorry. So the question is the speed test restricted to any kind of throughput licenses on the device? Am I getting it right? Yeah. Okay. No, it's not. It's just checking the bandwidth of the link. There's no requirement for your throughput licenses that goes into the devices itself.
So it's not restricted by the throughput limitation or how it just basically tests the capacity of the link
Edge to the hub, edge to edge, you can choose for yourself. Yeah, that's right. I'm sorry, is it that?
Is it per login? For example, if my colleague is logged on and he runs the speed test, would I be able to run?
No, it's one at a time. She clarified that point. She has done that. She has done that. That's why she knows about it.
Because you can duplicate the window and then you can run, right?
No, you can't. I told you, right? It's an internal daemon that is working in the backend to spin up those IPOF servers and do this test. And other than that, I mean, because of that limitation itself, I believe it'll just restrict you to one at a time.
Thank you.
All right. I'm sure everyone in this room has done a packet capture, looked at a packet capture in his life, right? Everyone, right? Now, if you ask me the number of customers we see or the challenge that we have with taking a packet capture at times is the requirements from the customer. When I say requirements, as soon as we go ahead and tell the customer, oh, you know what, we have to get some packet captures done over here. We have to put some ACLs in place, get the captures done based on those ACLs, blah, blah, whatever be the case. The moment we put that, there are some customers who have their own change authority board, a CAB, basically, who approves any of the change requests. Any kind of config changes that we ask the customers, we get rejected at that point. Because they have to go ahead with their own change authority board, get it approved. Once the approval has been done, that's where we are allowed to take the packet capture. Might be possible that we might lose that instance of the issue itself, the intermittent issues, if I can talk about. With SD-WAN Manager, we have made it very simpler again, just a 3-step process which will help us to capture the packets. There is no additional configurations again required. You don't have to think about any additional configurations that can be or that needs to be put on the SD-WAN or on those devices itself to capture the packets. Pretty easy. All you have to do, get into devices, troubleshooting, and you can see the packet capture over there. Hit the packet capture, you'll see the device is already selected. You just need to see what VPN you want to capture the packet on, what is the interface associated with that VPN. As soon as you hit start, it will go ahead, run the packet capture, and come up with a download as a PCAP. Just one just one restriction I would say over here is it can only capture 5 MB of packets or it can capture till 5 minutes, whichever comes first. There's a nice story that I was talking about, the intermittent issues. Some time back, during the days of vEdge, basically. So this customer came back with an escalation saying that at times for that particular branch itself, their Microsoft Teams users are going offline. They go offline for a moment, come back online automatically. Now, when we got that, we had a look at the topology. It was a very simple one. 2 vEdge devices having 2 WAN TLOCs and a TLOC extension in between them, and then follows the LAN network. When we ran the service path command itself, during a working scenario, when I was running the service path command, which gives you basically if this particular traffic between the source and the destination is getting load balanced or not. So I could clearly see there are 2 paths. Of course, one is the WAN TLOC, the other one is the TLOC extension it's taking. I had a hunch over there. Possibly, it could be very well possible that at times this Teams traffic is being dropped onto the TLOC extension, which could be causing the issue, but I had to prove it. So we go on a call with the customer, we showed him the tool. Okay, you know what? I understand you are in a pain at the moment. All I want you to do is, as soon as you see the issue, run this capture on the service side of that particular branch. And you get me the packet capture. Meanwhile, we'll join in as soon as you call up. And within the next 2 or 3 days, he encountered the issue once more. So they collected the captures, and as soon as we opened the capture, everything was clear over there. During the issue state, what I was seeing is the traffic that is coming from those particular sources, those are marked with the DHCP value of 0, default. Whereas, when it is coming back to a working state, that's marked as a EF. Now, what our vEdge devices does basically is, in such scenarios, vEdge devices calculate it as a new flow based on the DHCP value. So along with your source IP, destination IP, source port, destination port, it will take one more parameter, that is your DHCP. So what was happening here is, the EF traffic comes in, it was being put towards the WAN TLOC, and at times, due to the change in DHCP value, vEdge detects the same source and destination, but just because the DHCP value now changed, it was detecting it as a new flow and putting it onto the TLOC extension. And that's where our issue was. We went back to the customer, showed him the data, showed him how exactly vEdge load balancing works. At that point in time, he went ahead, looked into the LAN network and figured out there's some wireless controller in his network misbehaving, trying to remark the traffic at times. Very, very helpful tool, I would say. Very recently, I was troubleshooting one of the issues where I'm sure all of you might have used the SSH terminal that is available in our SD-WAN managers, right? In order to log into the devices. So I had a very peculiar customer coming in saying that I'm not able to SSH. I'm able to SSH from outside. I'm able to use PuTTY to SSH. Everything well and good. I'm able to SSH from my jump host, but as soon as I try to SSH from this terminal, it doesn't work. We took some captures. We were able to figure out there is a ACL configured in his line VTY itself, which was causing it not to happen. Pretty handy tool, right? Just last slide, maybe. You can use some filters also over here, like the source IP, based on the source port, based on the protocol, we can capture the traffic. Now, let's talk about the upload admin tech and tag cases. Now, this is just a good to have tool. Saves you some time, that's all. Not a troubleshooting one though, but yeah. Starting from 27.17.7, we can upload or we can generate the admin tech on the SD WAN Manager itself and upload it directly to the SRs to the TAC SRs itself. All you need is the TAC SR number and the token along with it, which can come from the SR itself. And all you have to do is just download it over here on the SD-WAN Manager, and you can directly upload from here. All it needs is the internet connectivity, of course, and a reachability to cxd.cisco.com. If you have that, you can straight away upload it from here. Save you some hassle of downloading it locally, opening up SCM, again uploading. It just saves you some time over there. All right, TAC case, again, from the tools TAC case, you can directly access your TAC cases, you can open new TAC cases. All it needs is, again, internet access and a reachability towards the SCM portal itself. The support for this one, it started with the 20.9.1. From there onwards, you can use your SD-WAN Manager itself to open new cases, to update any of the older SRs itself. Good to have tools, saves you some time, saves you some hassle, I would say. Next one, pretty important, underlay management tracing services. Now, till now we know SD-WAN, it's an overlay technology, right? Between two different sites, it goes ahead and builds those tunnels. We know it's an overlay technology. But think of it in this way. If at all your underlay goes bad at any point in time, your underlay goes down, will automatically take the overlay down, isn't it? We have a visibility about the overlay, but until and unless we utilize some external tools, we'll come to that, those external tools also in the upcoming slides, but until and unless we utilize some of those external tools, it's hard for us to imagine what is happening in the underlay. That's where UMTS comes pretty handy to us. So the support for UMTS started with 17.10.2010 release, and it can help you determine the exact number of hops that are there between two different sites. It will tell you about the path that your BFD tunnels are actually taking between two different sites. And not only the path, it will also tell you in each of those segments what are the loss and the latency. Pretty handy tool when you go ahead and troubleshoot some of the latency issues. Between two particular sites, let's say we are seeing some latency, we can utilize UMTS, see if the underlay has been behaving properly, if we are seeing a better amount of, or are we seeing any amount of loss or latency between those particular hops itself. Easy to use. You need to get into devices, troubleshooting, you would see the tool named as underlay discovery. You can use that, put the local color, the remote host itself, and the remote site color itself. And as soon as you hit start, it'll give you exactly the mapping between those two particular sites itself. What are the hops in between? You hover around a little bit on those particular hops in between, and you can clearly see what is the latency and the loss percentages. It actually leverages BFD kind of probes to get these values in the underlay. No any configuration needed, nothing required, no any external tools needed. Between two different sites, if you want to see how your underlay is performing, that's the best tool, I would say. All right, network-wide path insight, NWPI. Anyone in the room who has used it? Okay, great. NWPI is, I would say, one of the most powerful tool that SD-WAN can have. I consider it as a diagnostic tool most of the times. The reason being, let me put this scenario over here. Let's say I have an application sitting behind my regional hub. And from this particular branch, I have, let's say, 5 different hops in order to reach out towards the regional hub itself. If at all there are any issues with that application from this branch, If I have to troubleshoot it, I have to go ahead, jump in hop by hop by hop by hop. Every hop itself, I have to go ahead, I have to put a trace, maybe a packet trace, which gives me the FIA information, the feature invocation array, which is nothing but this application packet. What are the features it has gone through from the incoming till the outgoing of the device? Now this, I have to do it on 5 different devices. Again, take care of the returning traffic also. Whatever data I get over there, I have to collate that, and then probably I'll have to conclude, okay, it's so-and-so hop is causing the problem or not. With NWPI, the traces that we take, it is much, much simpler. Does the same thing, whatever I just said, but it's much, much simpler. All it does is basically, to the application data itself, it adds a certain metadata. And now what happens when we send that, whatever hops are there in between, all these devices will react to this metadata and send all that flow information towards our SD-WAN manager. All our SD-WAN manager has to do is collate the information from 5 of them, show it to you in single shot. We'll come to that. So this is basically what I was trying to explain. What it does is, it will go ahead, add a certain metadata to our application data itself and send it further. So as soon as it sends it further, whatever traffic or whatever hops are there in the path, they will automatically react, and we can get a true or a real-time visibility of the performance of that particular application itself. You can also use it for some design validations. Let's say we have a SaaS application, some of our critical ones, let's say Office 365 to that matter, and we have some policies deployed that, okay, Office 365 should be taking MPLS and whatnot. Maybe that's our policy. What we can do is, via NWPI, we can validate that design. We can see exactly if Office 365 is adhering or honoring to whatever policies I have defined or not. If we talk from the QoS perspective, it can exactly show what queues, or it can give you the QoS insight, which makes our troubleshooting much, much easier. I have a very nice scenario coming up in the upcoming slides. You'll see how easy it becomes for us by using these NWPI traces itself. Again, how it works, all we have to do is, the network operator, he goes ahead, he creates a trace. As soon as the trace is created, your data, your application or the original packet is again added with the NWPI metadata. And this metadata, as soon as it reaches to n number of hops, whatever hops are there in between, they will automatically react to the metadata and send the data towards our SD-WAN manager, the flow data towards our SD-WAN manager. SD-WAN manager will do all the collation for you, all the correlation between these particular traces. It will automatically do that, show it to you in one single slide itself, what exactly is happening. It will answer all your W related questions. We'll come to that. A little bit of timelines, don't have to bother about it. Just keep in mind, 1713 is where we have integrated NWPI with ICE. And by doing so, now the traces that we take is one step closer to the source of the problem itself. We can directly utilize use the user itself as our filter criteria. We'll come to that. There is one very nice scenario. 1714, one more important achievement, I would say, or a feature, that NWPI, we have integrated it along with 1000 ICE. So we can utilize all the data that we are getting from the 1000 ICE tests that are running, and based on that, we can take, or we can utilize it in NWPI traces itself. Again, a little bit of prerequisites. The data stream should be enabled, and this is how the filter would look like to you. If you get into the NWPI, you would see what is the site that you want to use, what's the VPN that you want to use, and you can take the traces based on the applications also. While you take the trace on the application, and this is where you need to understand, I'll take a little bit of time. There are 4 things that we can check over here: overview, application performance insight, event insight, and QoS insight. There are 4 tabs you can see on top, right? So start off with the overview itself. As you can see, the colorful pie chart over there, it not only tells you about what type of applications are being used over here, it will also tell you how many flows are associated with those particular applications. If you filter it based on the events, it can exactly tell you how many flows had local drops, how many had QoS congestions, how many of them had no response. I told you in the previous one itself, all your W-related questions would be answered in one single slide itself. That's how powerful NWPI is. If I have to show you what, I filtered that with all the events. So what is happening over here? The server no responses, right? Who? What are the flows that are impacted? What applications are impacted? We can get to know. Where, again? I got to know what is happening here. I got to know what flow is affected, where exactly is it affected. Between the SJ branch and the RTP hub MPLS is where we are seeing the issue. We'll get to know also, we'll get to know the when also. This is the time, this is the time when this particular flow was impacted. We can correlate this time with the user's complaint time and get to know exactly we are in the right path to understand. And not only that, it tells you about the why also. Why could this be happening? Because at this point, he's looking at the overall network between that particular hub or the spoke. Whatever underlays are there, whatever paths it is taking, this traffic is taking, it is looking at all of that in one collated information and gives you all that information clearly. If we click on that hyperlink, that'll actually, these particular time details are hyperlinks. You click on that, it'll take you to the completed flows for those particular traffic itself. If we get into the insight summary or the application performance insight, okay, some very interesting data it gives. Let's have a look. Who is impacted? Those are all the applications that are impacted at the moment. Or I chose those particular as my filter. These are the applications where I can see that I can choose exactly which path is affected. That's the SJ branch towards the RTP hub. What is happening? All the loss, latency, the client network delay and the server network delay graphs would be seen for each and every application of yours. If I talk about the when, and there comes the Sankey diagram that you see towards the bottom. It's a little messy, I know, but in your PDFs, I've put some arrows over there so that you can follow exactly what I'm saying. So if you see, let's talk about RTP audio to that matter. As you can see, RTP audio, it takes your SJ branch MPLS, backhauls towards the RTP hub, and then from the public internet it goes towards the New York branch. We have a very good score over there we can see for this particular traffic. If we take one of the affected ones, we can see the Amazon traffic, that's again going via SJ branch MPLS. The score was good till it reaches the hub. But after hub, we can see the score somehow has degraded. If we get into the graph now for Amazon, we would see exactly something similar to what you see towards your right hand side. That is what I have highlighted over there. You see the score on top, it has dropped at one point. And if I correlate that time with the client network delay and server network delay itself, I can see the SND has somehow increased. That delay on the server side has increased at the same point where the score has dropped. Which tells me that at some point in time on the server side, there was certain issue which caused the score to drop. One single trace based on the application, I have all that data. Now I can take this data to the server team itself, showing that, okay, you know what, this is what I'm seeing. I'm seeing a drop in your score. I'm seeing a rise in your latency. Can you take a look? Saves a lot of time of ours. And not only us, even for the server team. This is the best data they can have. Okay, if we talk about the event insight, now, we all know for applications, it really matters what is the path they are taking. Path getting asymmetric has always caused issues with applications. With NWPI again, we can clearly detect if there is any kind of flow asymmetry happening for any of our traffic. The way to do that, again, we start off with the who, where is it happening, what is happening. I've selected the event as flow asymmetry over here, and just follow the Sankey diagram over here. If I talk about one of the SaaS applications, MS Office, I can see it's taking the public internet of SJ branch, breaking out. There is no flow asymmetry detected over here while it goes to the SaaS cloud. But if I talk about the exchange traffic, there is a little bit of flow asymmetry detected between the SJ when it backhauls towards the hub site. And again, from the hub, when it tries to reach out the other side or the LAN side of it, there is a little bit of flow asymmetry detected. If you're having issues with your application, we can utilize all these events in one go itself and try to understand what could be the root cause of the problem. A very interesting scenario for QoS again. So let's say, when this site was being deployed, we had our requirements. Based on that, we went ahead and put some QoS in place. And the configurations that we had, we were giving Q0 to voice and video, having a bandwidth of 15%, Q1 WebEx 20%, and so on and so forth. Let's say one certain day, the CIO of the company is hosting all hands, let's say. And we know that during this point in time, there will be a lot of users logging into WebEx, attending that particular all hands itself, right? If I straight away go ahead and tell my execs, you know what, we defined this QoS long time back. There might be some tweaking, some increase in bandwidth to the WebEx needed because we are going to have this all hands very soon. I'm sure they might not agree to it. But as soon as I have this kind of a data, so what I'm trying to show here is during the all hands, there were some drops noticed. Based on the QoS insight, now I can clearly relate that data that the QoS drop has increased, and it actually, you can see in the Sankey diagram that the WebEx meetings which was utilizing Q1, there is near about 62 packets per second as a drop. Now, if I take this one single snapshot to my execs and tell them, look, in the initial days, this QoS might have been holding good for us, but not right now, as we have a lot of users have increased and we are having these events, we have to take some remediation. At least during these events, you should allow me to give more bandwidth towards WebEx. Or we should think of more permanent solution at this point that buy some more bandwidth for Gig 3. One single slide, one single trace would give you all of these information in one place. No need of going hop by hop by hop, running some packet trace, getting that data, and then analyzing yourself. We'll see to it in the upcoming slides. I have two very nice scenarios over here. Scenario 1. We have integrated NWPI with ICE, I told you, from 1713. Let's see how that helps us. So, all we know is NWPI, it gives you an insight about your path insight, application performance, QoS insight. But with the integration of your ICE starting from 2013-17-13, we can get one step closer to the specific user as the trace. We can utilize that. In order to deploy ICE, of course, your UI, your data stream should be enabled. That's one given thing. In order to deploy ICE, you need to get into the integration management, ICE. You have to put the IP address, username, password, and what VPN you want to connect it. As soon as ICE is integrated, let's get to a scenario now. So let's say one of the user starts complaining. One single user starts to complain that I don't have access to internet. I can use him as the source. I can use him as the trace information itself. I can collect, using Jack's name itself, I can collect the trace. And this is what I see. If you look at the colorful pie chart over there, you can see exactly how many applications are open or he's trying to use, and all the events are seen as drops. If I select that local drop as the event, what is happening? All the impacted flows are there. When I can see the time, correlate that with when Jack complained. If we see where, between the SJ branch, and it tells you why, and the drop cause, as you can notice, it says firewall policy. What's happening over here? If we click on that, on the hyperlink itself, that will take you to the completed flows page. And you can see Jack was trying to access box. The local drop at that point in time was 100%. You deep dive a little bit on that. Click on the next hyperlink. You would see something like this. This is the collated information that I was talking about. In this case, what we see is the action is drop. These are the class maps and policy maps that I have been using. And if you just click on that view policy, you can clearly see that for Jack, somehow there was a typo over there, which is setting his base action to drop. And that's why he was having this issue. So even if there are any kind of typos, even if any kind of design validations that you require, you can get it done. One more interesting scenario, I would say, integration with Thousand Eyes and underlay management tracing services. So again, your NWPI, it will give you the data about the path inside, the application performance inside, but going further with some of the feature enhancements, what we have done is we have integrated Thousand Eyes test information also into NWPI. We can do that. And by utilizing both UMTS that we saw in some of the previous slides, by utilizing both UMTS and the Thousand Eyes test data, we can come to a conclusion. We can see how exactly is it resolving our problem. Let's see. I have a very nice scenario over there. Okay. How to configure Thousand Eyes? You need to get into the Thousand Eyes dashboard, applications, account settings, profile, and user API tokens. You need to get the bearer token there from Thousand Eyes dashboard itself. And here, you need to get into the administration, Thousand Eyes user API tokens, put the username, put the bearer token, and that's how you merge both of them. After this, if you get into NWPI, you would be able to see what kind of Thousand Eyes agents are available, so that we can take in those particular data, that test data that we are running at the moment from these agents, we can take in all of them from via NWPI itself. Pretty nice scenario. Okay, just keep an eye on to your right hand side towards the diagram over here. Let's see. Yeah, go ahead, please.
Question here. So Thousand Eyes here, is it using the data like the statistics from like end devices or a switch or something like that? Is it?
Anything is possible. You can take it from an enterprise agent, you can take it from an endpoint agent, doesn't matter to us. So as you mentioned rightly, so the question was, is Thousand Eyes taking the data from the switch itself, or is it an endpoint agent? It could be anything. All we are taking care over here is, once we have that integration between the Thousand Eyes and SD WAN Manager, we can select what tests are we running. Based on the test capability itself, I'm populating the data. So it can be any agent, to answer your question. Now, let's say we had a SaaS application somewhere, Office 365. In order for San Jose branch to get to that SaaS application, they have to go via the Seattle DC. That's the topology overall. Now, at one point in time, the San Jose branch, they're complaining that they're seeing some slowness with this application. If we have Thousand Eyes integrated, now let me put that again. If you see, I can divide this into two parts, isn't it? The BFD tunnel that will be built from your San Jose branch towards the Seattle DC, and then from Seattle DC, we will have a breakout, a DIA circuit towards the SaaS application. Now, these two parts again will be taken care by two different tools, but we don't have to worry about it. If the integration is good, is done, we should be able to see the data something like this. The first part, of course, is your SD-WAN branch towards the DC, and that underlay information is populated by UMTS. The rest that you see, 26 routers, those are your internet insight that is populated by your Thousand Eyes data. So if you see, over here, between the branch and this DC, I'm seeing very minimal loss or latency at the moment. But as soon as we click on those 26 routers, it will pop up the whole picture. I can clearly see that at one point in time between one of the segments, I can clearly see the response time has increased, the latency has increased somehow. So we combine two different tools over here. We are combining the Thousand Eyes test data along with UMTS. We are seeing exactly how many hops am I taking in order to reach the SaaS application from a certain branch. Makes our life much easier, I would say. As soon as we take this data, we know who is managing these particular segment, whoever it is managing. We can take it to them. Saves a lot of time of theirs also at any point in time. They can look into this data, they can jump into those particular routers itself and see why the latency has increased. All right. Coming back to build your own API workflow. Yeah, please. No, you can use it. You can use customs also. You can use customs also, and you can also use it just for your normal BFD traffic also. So it doesn't matter. I mean, SaaS application, it makes the use case much more prominent, I would say. But you can do that. So build your API workflow. Why do we need these APIs? These are some of the reasons I could figure out. Manually doing tasks which are repetitive, tasks which are mundane, they need to be automated. And for all these tasks, again, we need some dedicated human resource, right? Why do we want to utilize them for these repetitive tasks? We can actually automate these so that we can utilize our resources accordingly. For any of those critical work, we can utilize our resources. So SD-WAN Manager APIs, it has a rich set of APIs, as I said before also, and we can categorize them, we can monitor devices, we can configure devices, we can query some of the aggregate data also via these APIs. And the base URL starts with your SD-WAN Manager IP address port number /data service. You would always see it as /data service, and then your APIs actually will follow. So the base URL stays the same always. Now, the Swagger-based API page for our SD-WAN Manager. Anyone used it ever? On your browsers, actually, if you just drop in your SD-WAN Manager's IP address, port number, /API docs, you would see a similar kind of a page. You would see the Swagger API page. You can actually try out all the APIs that are listed for our SD-WAN Manager from the same browser itself. You can actually try out and you can do your post, put, all operations from there itself. Now, interesting story. Need of this workflow. Okay. Before that, how many of you are aware of this SD-WAN Manager disaster recovery? Anyone? Has it in their network? Okay, one, good. So, for all of you, let me simplify what exactly the DCDR workflow basically is, or what it does basically is. We have our vManage or our SD-WAN Manager in the DC. We have a disaster recovery also along with it. Now, the basics of this disaster recovery is, in real time, whatever config changes are happening in the DC, whatever stats changes are happening in the DC, everything in real time will be replicated towards our DR. Under the hood, if I have to say, what it does basically is, your DC will create some export IDs. And this is nothing but a tarball of your configs. Every 1 hour, let's say I have set it to 1 hour, every 1 hour it will go ahead, create a tarball of this, send it towards the DR. Now, the DR, it has its own authentication mechanism, don't want to go deep dive into it, but once it gets the tarball, authenticates it that it is from a legitimate source, goes ahead, untars it, copies it to everyone. Now, why do we need it? Let's say there is a need that your DC is suddenly going completely blank, is completely down. As soon as we move to the DR, we should have the latest set of config DB over there. We should have the stats which were there, which were seen for our devices, should be seen over here. So in real time, this replication keeps on happening in the backend. At any point in time, if I switch over from the DC towards the DR, I would see exactly the same amount of stats and config data that was the last replicated one. Let's say 11 AM is the last replication success was happened. 11:30, if I change it, if I switch over to the DR at 11:30 itself, till 11, whatever changes had been done over here, everything will be seen on the DR in real time again. So this replication goes ahead in the backend. Now, coming back to the problem. So I keep on working with a lot of BFSI customers. When I say BFSI, these banking customers in India. And these guys have some requirements. These guys have some requirements from a governing body, or you can say it's one of the major government banks. They have their requirements put towards these banks that you should have DCDR in your network. That's one. Point number two, every quarter they have to do a DR failover and send the results to the governing body. That's the audit requirement. That's their validation, everything. And they have to manage that. And what we figured out some 1 year back, I would say, what we figured out is most of these banks, while they go ahead with this DR failover test, they're getting stuck. They're seeing random issues here and there. They're not able to do the failover test properly. We had to ease it somehow. So what we did basically is we gave them a pre-check mop. What we told them is, if you look at the diagram itself, if they are moving from the DC to the DR, let's get some pre-checks first of all done for you guys. If the pre-checks are all valid, that's the point you can go ahead and do your DCDR failover. Now, we prepared a mop for them. It's nothing fancy. All you have to do is get into the DC, check a few things in the GUI. Get into the DR, check a few things in the GUI itself to confirm. So the first one to start off with is check in the disaster recovery page if all the nodes are seen in green and in the last replication has been a success or not. You get into the cluster management page. These guys are deployed and all having 3 nodes, somebody having 6 node clusters. So in cluster management page, you should see all these vManage nodes, all these nodes in a ready state, and again, each of these have different containers inside, right? Your SD-WAN managers has application server, messaging server, config DB. All of these containers should be in a reachable state. And this has to be checked again, both on the DC and the DR. Most important one that we figured out where customers were getting stuck is the serial list check, the full mesh check. Now, in the serial list check, if you run the command show orchestrator valid vsmart in the validators itself, it will tell you what are the active number of SD-WAN managers and controllers. Let's say I have a 6-node cluster. So I have 6 SD-WAN manager. Let's say I have 4 vSmarts or controllers at that point in time. With this output, I should see 10 UUIDs over there. And this 10 UUIDs should match on all the validators. That's a mandate. You should have it in a full mesh always. That's where these guys were missing it. And that's where they were landing into trouble once they have shifted onto the DR, so the vBonds goes unreachable, and so on and so forth. Issues started. Last but not the least, send to controller should pass. All of this, once we gave them a pre-check MOP kind of a thing, believe me, the faults reduced to less than 2% after that. Every one of that customer was getting stuck. With this pre-check done, all a success suddenly. We don't have any complaints from them. Now they can do their DCDR replications, their DCDR failover tests on their own. They don't even need Cisco at this point in time due to these pre-checks. But while we were doing that, I was thinking back of my mind that, you know what, if all of this data, I can somehow get the exact APIs for these, I can probably put up a script for them. All they have to do is run the script. The summary is there within the next 5 minutes. Saves near about 45 minutes of one guy's job. So I started figuring out the APIs for these, and I could figure out, in order to see the local DC, /data service, disaster recovery, local DC. Again, for checking if it is a success or not on the GUI, you need to get into /disaster recovery details. The DR status will tell you which is the primary, which is the secondary. The cluster management list will tell you if the nodes, all the SD-WAN manager nodes are in a ready state, and cluster management reachability will tell you if all those containers that are running inside these particular SD-WAN manager nodes are in a reachable state or not. Once you get that, the full mesh check, it can be done via data service device orchestrator valid vsmart, and you have to use the IP address of these validators one by one. In order to send to controllers, you need to use this particular API. I collated all this API, put it into a Python script, and you can see that in my GitHub page at the moment, the DR pre-check. It's using this Python script. All you have to do is give it the username, the IP address, username, password of your SD-WAN managers. It will go ahead, do all these checks, and come up with a summary list saying that if everything is up, if everything is success or not. And not only that, the serial list check part, I put up a logic over there. Those 10 UUIDs which it was getting, is it the same for all the validators or not? That's where you will see all the vBonds. You can see if it is passed or not. With the send to controllers, if it is going to a success or not. All of this summarized within 5 minutes, I'm telling you. All you have to do is fork this particular script, utilize it, use it in your network. If you have any concerns on that, do reach out to me, I would say. All right, that brings us to the key takeaways, where we had a look at the overview of SD-WAN, we had a look at some of the monitoring challenges, had a look at some of the tools, And again, in the API workflow, we had to look at the DR failover checks at the moment. With that, guys, I'll just open up for any questions.
Like, if the application is TLS 1.3, is endpoint, does it work accurately, or is there issues we can cause?
If the application is TLS 1.3, I didn't get that question. Next.
Basically, TLS 1.3, all the headers are encrypted. Only the
With the NWPI, you mean?
yeah, NWPA, all the flows.
Shouldn't matter. Shouldn't matter. It should be able to still utilize the data, and it should be able to get it. Maybe if you can tell me what specific application, maybe after the session we can take a look. Any other questions, guys? Yeah, please. Go ahead.
The API, the DR API you told us and showed us, why can't Cisco build it as a feature in the vManage?
They can, why not? You know what, they can build it. But the only problem that comes is, what are your customer scenarios? Now, I had my own script, so I can take care of how many SD-WAN Manager cluster you have, how many vSmarts you have, how many vBonds you have, okay? Now, if you want to implement that as a feature, it can be out of box. Of course, right now I'm in the same path. Actually, you put up a very good question. Right now I'm trying to see if at all I can utilize some AI in this, okay? Build a MCP out of it, so that next time you don't even have to run my script. You have to just, via natural language itself, you can ask it, okay, can you go ahead and do the DR pre-check? It'll go ahead and do it for you. I'm trying that. I'm trying that at the moment. So in process, you can see. Please, there was a question.
Regarding the packet capture, are there any plans in the future release to maybe increase the time of the capture or the size of the capture? It is limited to 5 minutes.
Right. No, we have the plans. We have actually put that as a feature enhancement at the moment. It's just that when is the development team going to find a sweet time to fix it? So there is already an enhancement file for that one, but I really don't know exactly when is it going to be fixed or which release. Probably in the upcoming release we should be able to. We're trying to put as much story behind it as possible to get that feature in. So let's see. All right. That do complete your surveys, guys, and I really need that honest feedback of yours where I can improve and what all things you want to see. If you still have any further automation requirements, do drop me a note on the WebEx Teams. We can work along, we can create that. Continue your educations, and I'd like to end my session. You guys have been a wonderful audience. Thank you and namaste.